All right, senior math. Welcome back. Happy Friday. All right, so we are going to try to answer these few questions using our standard deviation skills that we've been practicing for the past couple of days. So an archaeologist was collecting pottery samples at a Native American kiln sites. The samples were analyzed to determine their chemical composition and what they were made of. The percentage of iron oxide in each of the samples is listed below: 1.28, 2.39, 1.50, 1.88, and 1.51. So we have a couple of things that we're trying to calculate. So first thing we want to do is we want to calculate the range of the data. Then we want to calculate the standard deviation. And then we want to compare the range of the data and the standard deviation and see how many standard deviations will fit within that range of data. Because this is something important that we'll sort of briefly, or that we'll jump into later in the following weeks of comparing range and standard deviation. But let's talk about calculating the range first. So we know range as just your highest number minus your lowest number. We use this a little bit when we did our box plots. So when we want to calculate the range of the standard deviation, I need to look for my highest number, which is 2.39, and my lowest number, which is 1.28. I'm going to subtract these, and then that will give me my range. So that turns out to be 1.11 is our range. Now, that obviously doesn't tell us much. It just tells us our points are within 1.11 distance from each other, but it doesn't really give us much information about the variability of our data. So that's where we jump into that standard deviation once again that we talked about. So I'm going to give myself a little bit extra room. And let's calculate the standard deviation. Now, we talked about having two different ways of calculating standard deviation. We learned last Friday the first method, and then we learned on Wednesday the second method. I'm going to do the second method because I personally find that one easier, but if you prefer the first method, don't worry, you can still keep using it. So I'm going to create my table with my terms and then their squared values. So I'm going to have 1.28, 2.39, 1.50, 1.88, and then 1.51. Now, once again, once we got each of those values, we're going to square them in the next part. So I'm going to square them in my next column, 1.6384. I'm going to get some uglier decimals with this. 5.7121, 2.25, 3.5344, and then lastly 2.2801. So those are the squared values of each of them. Now, our step after that, once we got the squared values, was we needed to take the summation of each of these columns. So I needed to add all my normal terms together and add all my squared terms together. So the summation of my normal terms on my left-hand column turned out to be 8.56. The summation of my squared terms on my right-hand side of the column turned out to be 15.415. And now once we got each of these values, we plugged them into our formula. Now I don't have the formula up here, but it is our standard deviation or our variance is equal to the summation of our squared terms minus the summation of our terms squared divided by the number of terms that we had, then once again divided by the number of terms we have. That is our standard deviation second method formula. So all we have to do is take these two values and plug them in. So the summation of my squared terms is going to be my 15.415. And then this is minus the summation of my terms squared, which is my purple 8.56. And this is going to be squared divided by the number of terms I have, which is 5, and then divided by 5 again. Now, once again, we can plug this whole thing into the calculator, but if you're putting it into a scientific calculator, I recommend putting parentheses around that top half of it so it's dividing by 5 correctly. But if we put that in, we get s squared is equal to 0.152, which then our last step is to take the square root to get our standard deviation by itself, just s, which is going to turn into 0.389. So our standard deviation is 0.389. Pretty simple, pretty easy. So going back to that, we had a standard deviation, which is 0.389. Now we want to see, okay, how many standard deviations will fit within this range of data. So what we can do here is if we're looking for how many will fit within the range, we're trying to divide up our 1.1 distance into sections of 3.89. So what we're going to do is we're going to take 1.11 Oh, if my calculator will work right. Sorry about that. There we go. Okay. So what we're going to do in order to figure out how many ranges or how many standard DVs fit within our range, we're going to take a 1.11 and we are going to divide, as soon as my computer cooperates, divide by 0.389. And that's going to tell us how many standard deviations will fit within that range. So 1.11 divided by 0.389 is going to give us 2.85. Now, this number 2.85 might not seem very important, but it's going to be helpful in the future because this represents how many standard deviations away from your mean are we likely to fall. So we're only going to fall one standard deviation typically above or below our mean, but at maximum, we're typically only going to fall within 2 standard deviations of your mean. At the most, sometimes we get to possibly 3 standard deviations away from your mean, but that's very, very unlikely. And that's something we'll talk about in the future when we talk about probability and trying to predict how likely a certain event is happening using standard deviation. So this is something we'll come back to in a while in the future. But for now, we did all this work. Let's try to find an easier way for doing it. So let's try to see if we can calculate how to find standard deviation using a calculator. So you should all have access to your Desmos graphing calculator on Schoology. So you're going to, it should give you something like this. And now in order to calculate standard deviation, I'm actually going to step out of the screen for a little bit. We are going to go to our Desmos graphing calculator, and we are going to click on this little button at the bottom right here. That's going to pull up your keyboard. Now in that keyboard, we are going to go to the functions button on this right-hand side. So we click functions, and then it has these couple of different options at the top. Now we are taking statistics right now. We're in senior math statistics. So we're going to click on stats. So I click on stats, and then my last step is I need to click on STDEVP. So what this stands for is standard deviation population. So we are going to click on standard deviation population, and it's going to create these little SDVEP with parentheses up here. And now all we need to do from here is type in our data into this standard deviation parentheses. So we had 1.28, and then we're going to put a comma, and then we're going to do 2.39, and then we'll put another comma, 1.50, comma, 1.88, comma, and then 1.51. And if we look, the value that they gave us was 3.89, which is exactly what our standard deviation came out to be when we calculated it by hand. So this is a much faster, much more efficient method of calculating standard deviation. And if we look at that functions, there's actually a couple other things in here. So if you want to find what is the mean of your data set, you can use that. You can find what is some of the quartiles of your data set, your maximum or minimum, or your median of your data set. All of these things show up in here. And there's a couple other things we'll use later on in the year. Notice there are 2 standard deviations. There's STDEV and STDEVP. We're going to use the one that's P. There's a slightly different way of calculating standard deviation when you only have a sample of the data compared to the entire population. And that changes your answer just by a little bit, but we are going to use the STDEVP whenever we're calculating standard deviation. So there's a lot of cool, nifty features on here. So mean is another one we'll often use. So going back to our math, let's look at one other example. So use your calculator to find the mean and standard deviation of this data set. So 4, 1, 3, 1, 3, 1, 2, 2. So I want to find the mean and standard deviation, just like what we were practicing on Friday with my with our paints that we are looking at are 2 different brands of paint. We can open this up. So I have this data set here. So once again, I'm going to pull up my calculator, go to my functions, go over to stats, and I'm going to start with my mean. So I'm going to take the mean, and then I'm just going to do 4, comma, oh, this is annoying, 1, comma, 3, comma, 1 again. I need another 3. Looking at the wrong spot. 1. Gosh dang it. And then 2, 2. All right. So our mean of our data set is 2.125, which is we can easily calculate. And the last thing we can do is we can do our standard deviation. So rather than typing all that in again, I'm just going to copy and paste this. If I highlight all of this data up here, copy it, paste it, we get a standard deviation of 1.05. So our mean is 2.125. Our standard deviation is 1. So it tells us our data is pretty not too variable. Everything is within one standard, or everything is typically only going to be on average 1 standard deviation away. So only 1 point away from our mean. But that's how we can use our calculator to simply easily calculate standard deviation. So once again, pull up Desmos, pull up the keyboard, click on functions, go over to stats, and then it's right there, STDEVP. And that is your standard deviation using calculator. All right, so that's where we're going to end it for today. And you will get started on a project that Mr. Jarvis will most likely explain in just a minute.